Hello, everyone. My name is Almas Pernyashev, and today I will be presenting the Soundwave project. And this project is I this is a programming kind of challenge that I did, and also it consists of the two parts. First of all, is um, we're going to be using the equation of the sound wave and changing the parameters, something like amplitudes, wave numbers, and also and all the other stuff, and to see the how um, our sound wave equation is going to look like. And the second part is this one that you see on the right hand side, which is going to be audio spectrometer. And let me start with the first part. So in the first part, this is my code that I implemented by using a Python and with a matplotlib um, package for the animation and NumPy for using some writing some mathematical equations. In here, this is a sound wave equation which is going to be dependent on our amplitude, wave number, angular frequency, phase. Our wave number is going to be dependent on the wavelength, and yeah, this is kind of logically I created as much as possible as the real sound wave equation. And currently, we have an amplitude of our wave equation of 2, the angular frequency negative 0.1, so which means it's moving really fast, really slow from the right to left. We have a wavelength of 10, so it's going to be the distance between the crests is going to be really far, and the phase change is going to be currently stays at pi. So let's see what happens as I run this program. All right, so my sound wave it actually moves really small with a amplitude of 2 and with a phase and with a wavelength between the crests of 10. And let me try to change my parameters and see what happens. So now I want to make my wavelength, the distance between the crests, less. So I'm gonna place here a 1. I want to make it move it from the left to right now, so change its direction. And I want to make it so it will move way faster. So as you know, the angular frequency is going to be proportional to my real frequency. So as I change my angular frequency, increase my angular frequency my frequency is going to change as well, increase as well. And the amplitude, let me make it a little bit bigger. Let me make it 10. And let's see, and let's verify this. All right, and as you can see, the amplitude is bigger, the distance between the crests is smaller, and it's moving a little bit faster, right? All right, and in the right direction, from the left to right direction. So, all right, this was my uh, first half of the project, and let's move on to the audio spectrometer. In the audio spectrometer, this is my code, and I use the package PyAudio, which is going to be helping me to catch the signals and sort the signals from the environment and plot. And I'm going to be using matplotlib to take the signals and plot it on the on the sound wave plane. And the data there is not is not for the scale, since the data is going to be really squeezed, and I'm not sure what's going to be constant multiplier to actually to make it more uh, a bit better. So yeah, this program is there's a lot to work more. And this is my audio spectrometer, real-time audio spectrometer. And let me actually play with this audio spectrometer by changing the frequency and see some really cool patterns. So on the left hand side, we have an online tone generator with a frequency of the 585 hertz. And let me play it and try to vary my frequency. All right, sorry for these noises. Was some visual uh, representation of how we can actually play with our frequencies to actually to visualize these patterns. And there's a lot of to work still to actually to change that I want to do. But this was my project. Thank you for watching.